So 5.4c, the last bit here, dealing with matrix operations. And we're looking at the story problem, example 7. So we have Dalton's Dairy produces no-fat ice cream and frozen yogurt. And let me get a picture of that chart. All right, so there's a picture, and this is how much no-fat ice cream and frozen yogurt these people sell in a week at particular stores, at store 1, 2, and 3. All right, so really, there's our matrix there. So what they're wanting to do is find out how much profit they make at each store. So if you continue below the chart, it gives you a little bit more information. It says that each gallon of no-fat ice cream, they make $4 profit. And the frozen yogurt, they make $3 profit. All right, so it says use matrices to find the total profit on these items at each store for the given week. All right, so here we go. First of all, let's write the matrix. So this is Dalton's Dairy produces 100, 80, 120, 160, 120, and 100. Okay, so there's our matrix. All right, our profit matrix looks like this. $4 off the ice cream and $3 off the yogurt. All right, so now one of the things that you do is you multiply the profit times, the quantity of ice cream sold to find out how much profit they made on the ice cream and how much profit they made on this one here. Okay, so what we're going to do is we're going to multiply these two together. All right, so first of all, we have to write what type of matrix this is, what order this is. So this is a 2 by 3, and this is a 1 by 2. Okay. Now look what happens here. I've got a 2 by 3 and a 1 by 2. Can those be multiplied this way? No, they cannot. But what if I multiplied them a little bit different? What if I wrote the first one as a 1 by 2 and the second one as a 2 by 3? Now can they be multiplied? Yes. Okay, so very important to see that multiplication, you can't take 3 times 4 and get 12 and 4 times 3 and get 12 in matrices. Okay, it makes it whether it's possible to multiply or impossible. This one makes it possible. Okay, so my answer then is going to be a 1 by 3 matrix. So let's go ahead and write that as a 1 by 3 matrix. 1, 2, 3. There's my 1 by 3 matrix that I'm going to get in my answer. Okay, so what I'm going to do is I'm going to put D right next to it, so I've got the right order, and there we go. So I just took this and moved it down. Okay, so this thing right there is row 1, column 1. So row 1, column 1. So we have 4 times 100 plus 3 times 160. So we have 400 plus 480. So that gives me 880. And then this next number is a 680 when I do all that, and the next one is 780. So what do I have? Store 1, because that's what our columns are labeled. Store 1 sold 880, store 2 680, store 3 780. Or that's how much profit they made off of the ice cream and the yogurt that they sold. Okay, so if we have a single row like this here, it's called a row matrix. If this were switched and we just had a single column, let's say we had a matrix and this was the only thing that we had here, was something with 2 rows and 1 column, that's called a column matrix. All right, anyway, we're going to go to matrix equations, which are really short and simple because we're not going into any details here. We're not actually going to solve them. We're just going to learn how to write them and understand what they are here, and then we'll be done with this section. All right, so if we have a system of equations, 4x plus 2y minus z equals 3, and we did this before, way back in the beginning of this section. I think it was 5.2 maybe. 4x plus 5y minus 2z equals 1. All right, so first thing we're going to do is we're going to write a matrix equation equivalent to this system. So what we're going to do is we're going to take all the coefficients and give them their own matrix. I don't have any y's there, so I put a 0 there. I've got to have something to fill in the space. Okay, so I'm going to make that. Then I'm going to write an x, y, z, depending on how many rows I have. But since I have 3 rows, I'm going to put an x, y, z there, equals my constants, 3, 5, and 1. Okay? So, if this is A, this is X, these are capital, these are naming the matrices. So I named each one of these matrices. This whole one is A, this one I'm going to call X, and this one is B. Then I can write this matrix equation as A times X, equals B. And you're done. That's all I wanted you to do. Write the matrix equation equivalent to the following system of equations. And in the next section, we'll figure out how to do problems like this. I'm at this park in California, and it seems whenever I make these lectures, there's either airplanes flying at the airport that's next to me, or guys driving cool little lawnmowers as they're mowing the lawn, or that reverse beep, beep, beep going on as people are backing up, or people playing frisbee golf and hitting trees with their frisbee. So lots of stuff going on here today. But anyway, that is 5.4c, so we're done with 5.4.